Alrighty, so we talked about center, shape, and spread. Center being median or mean, spread being IQR, range, or standard deviation, and then shape being one of the 5 that we listed above. So now let's talk about the U, which are some unusual features, and I'll be completely honest with you. Gaps and outliers are going to be the most common, but still having a peak or a cluster in your data is worth noting because that'll give us some insight as to if we're unimodal or bimodal. Now, a gap is when there is missing data at a specific value or interval. A peak, often referred to as the mode, is the most common type of response value. And then an outlier is an extremely small or an extremely large value. Now, we actually have a mathematical rule for an outlier, so you don't have to guess and check here. So what we're going to do is we're going to write this rule in, but our rule is the following. If the value is less than Q1 minus 1.5 the IQR, then we call that an outlier. Or if it's greater than Q3 plus 1.5 the IQR, we call that an upper outlier. So this is an upper outlier, this is a lower outlier. And these two little equations here, we're going to call these the fences. So if it's outside of our fence, we call it an outlier, and then we just have to identify, is it on the lower end or is it on the upper end? Now, here we have a following data set, which describes the number of hours of sleep a student obtains after a Friday night football game. So here for my summary statistics, I see, oh, there's 15 students that were surveyed. Here's all their values. I could find the IQR, the max. I can interpret these values, etc. So it says, describe the shape of the data based on 2 pieces of evidence. So looking here, if I were to just draw on my data set, I'm going to have this tail towards the right. So the distribution of hours of sleep is going to be skewed right, since number 1, it's skewed right based on the graph. And the reason I got this value was because of the tail. It's pointing to the right. Now, if I'm skewed right, I have to think about what's the relationship between the average and Q2, or the median. So looking here, the average is 8.4. and my median is 8. So when the average is greater than the median, right, it's because the average is being pulled towards that extreme value. So also, since we're also skewed right, since, again, the average is greater than the median. And you can kind of see here the inequality points to us in the direction of the skew. Average comes first. So those are 2 pieces of evidence that would indicate that this distribution is most likely skewed right, and that looks like a strong skew. Now let's determine any unusual features of this distribution. So let's check the easy one here. I'm actually going to erase this tail that I drew. Let's look for gaps in the data. So the first gap I see happens right here at 6, and then 7, 8, 9, 10, 11, and then I see a huge gap between 12 and 17. So the first thing I'm going to do is I'm going to list the gap in the data, and I'm just going to write this out here. So let's see. So the first thing I notice is a gap at 6 hours and between 12 and 17 hours. The other thing I notice is that there was a peak at 7 hours of sleep. Now, the last type of unusual feature that we have to point out here are to see if there's any outliers, and I'm getting a hint that this one might be an outlier. So let's go ahead and show that mathematically. Now, what's going to happen here is when you're asked to describe a distribution, you don't have to pick all 3 because I'm picky as a person. I'm going to make you list all 3 during practice in class. But on the actual AP exam, rest assured, you only have to be able to identify either the gap or the outlier. Or if there is none, just tell me there's no unusual features. So let's take a look here at using our IQR rule, the outlier rule. So the first thing I need to find is the IQR, so Q3 minus Q1. So I know typically you're used to going vertically for math, but in this class we do a lot of horizontal expressions, and people are always like, what does that mean? Well, I'm so glad you asked. Here's the IQR, and the IQR is Q3 minus Q1. So instead of writing it beneath here, I'm actually just going to keep going sideways. So Q3 is 10, Q1 is 7, so my IQR is going to be 3 hours. All right, so let's check now for the lower fence. So Q1 minus 1.5 the IQR. So I'm going to take 7 minus 1.5 times 3. So if I have an observation that is less than 2.5 hours, that would be a lower outlier. And for Q3, we're going to check the upper end of the distribution. So now I'm going to do the same thing, 10 plus 1.5 times 3. Now, if there's an observation greater than 14.5 hours, that would be called an upper outlier. So looking at my data set here, I look, well, no observations less than 2, or 2.5, so I don't have any lower outliers. But I do have one observation above 14.5, and that's going to be there at 18. So I need to answer and describe some context here. So this is what we are going to say. So there appears to be an upper outlier at 18 hours since this value is greater than 14.5 hours, the upper fence. And there's multitudes of ways to say that, but in AP Stats, we're going to focus on this ACE model. In order to ace our questions, we need to do 3 things. We need to answer the question. We need to give context to the question, and we need to explain why our answer makes sense. So usually we explain using a since or a because statement. So there appears to be an upper outlier. Yes, that's our answer. At 18 hours, this is our context, since the value is greater than the upper fence. So if you have those 3 elements, 9 times, okay, maybe like 8 times out of 10, you're going to get full credit for the response. So you can see we identified the gaps, the peak, and the outlier. So we just check these few things when looking at distributions. This will make a little bit more sense, though, once we start using graphs to describe distributions. So it is normal practice in statistics to address any unusual observations within a data set. Above, we could see there was an outlier, so suppose in order to address this problem, we remove the outlier from the data set. So now here's our new value. So let's go ahead, let's look at the original. Here are each of our values here, 15. Here's our graph. And now let's look at the new dot plot here. So you can still see the gap at 6, but now I've removed the gap from 12 to 17. My sample size decreased, my mean decreased, my standard deviation stayed roughly about the same. And then our min didn't change, Q1 didn't change, median didn't change. Oh wait, am I looking at the wrong thing? I'm looking at the wrong thing. Mean decreased, standard deviation decreased, the min and Q1 didn't really change, the median slightly changed, Q3 slightly changed, and the max significantly changed. So let's describe these changes for our statistics. So I'm just going to type it out. Sorry, you got to write it out. Well, the biggest ones that took an impact were that the mean and standard deviation, and then you can also throw in as well as the max. Okay, here we go. The mean and the standard deviation both decreased. The max also changed. Whereas the min, Q1, Q2, Q3 were only slightly affected or slightly adjusted. Now, thinking about this, we've changed some of the unusual features, but now that extreme value has been removed, so most of the data is going to be closer together, so that's going to change our spread of the data and could possibly change the center of the data. But notice that when we were marking down these summary statistics here, they were a measure of where the observations were located. So these deal with location. So even if I have another number in the data set, whether it's extremely large or extremely small, it's not really going to change the location of where the other values are. But the mean and standard deviation, these both take into account the overall data. Meaning that if I put an extremely small or an extremely large value, the mean and the standard deviation are going to be heavily accommodating to that. So the way we reference this in stats, if a summary statistic has a minor change, this is because it is what we call a resistant measure. So we're going to write that in, a resistant measure, meaning it's going to have little change on extreme values. And this is usually because the statistic measures a position. So the examples are going to be the median, the IQR, and the quartiles. So those are what we call resistant measures. They aren't going to be too greatly affected by extreme values. Now, if it does experience an extremely large change, that is because it is what we call a non-resistant value. Meaning that this statistic measures overall trend. And so examples for that are going to be things like the sample mean, the sample standard deviation, the range. Those values are going to be greatly influenced by those extreme values. So thinking back now to the shapes of the various distributions, so I'm actually going to scroll back up here so we can stamp a key point. Looking at the shapes, right, I talked about the relationship between the mean and the median. So if you're symmetric, the mean and the median are going to be approximately equal. Those are going to be good uses. The average won't lie to us. But if we're looking at a skewed distribution, well, if you're skewed right, the average is going to be way overreported. And if you're skewed left, the average is going to be underreported. So what we need to do here is we need to decipher when we're going to use which type of statistics. So if a distribution is skewed, and I'll just go to green here. So if a distribution is skewed, we're going to want to use resistant measures. So we will use the median and the IQR. And so this will be our center, and this will be our spread. And then we'll be able to tell the shape based on the overall data. Now, if a distribution is symmetric, meaning unimodal, bimodal, uniform, or just approximately symmetric, since the data is going to converge towards the center there, it's got a pretty picture, we can still continue to use the average and the standard deviation. So again, this is how we do it by hand. Don't worry, we're going to learn some techniques on how to make this process a lot quicker, and we're going to do a lot of practice on this. But the next few lessons are going to focus on quantitative displays, meaning we're going to learn about 4 different types of graphs, and in each of those graphs, we're going to learn how to describe the data, how to find the summary statistics. But when we are asked to describe the data, I want your mind to go to cussing and BSing. I want you to tell me about the center. I want you to tell me if there's anything unusual, something about the shape, and something about the spread. Those are typically the 4 categories that are looked at when we take our AP exam. So the next few lessons will focus on those various quantitative displays. So stay tuned on learning how to describe the data for different graphical displays.